plus 3. Example 2. Divide given polynomial 3x square minus x cube plus minus 3x plus 5, my god, it's a big polynomial, by x minus 1 minus x square, even bigger, and verify the division algorithm. Now whatever we did orally here in this example, we're going to do it manually here. Now the trick and the tip, they both come into practice. Whenever I am writing the dividend, the trick is I write it in descending order. Remember, it's a cubic polynomial, so I'm going to write the cubic term first, then the square, then the linear, and then the constant term. Similarly, when I look at the divisor, it's going to be the quadratic term first, then the linear, and then the constant. Right? Now once I divide, I'm going to divide x minus x cubed by minus x squared. That gives me the number x, and hence I get minus x squared into x as minus x cubed. Then x into 2, right? X into x, that gives me x squared. X into minus 1 gives me minus x. Now once you subtract, the signs change. After the signs change, we are left with 2x squared minus 2x plus 5. Same procedure repeats. Minus x squared and 2x squared, when we divide the 2, I get minus 2. Remember, hence the quotient minus 2. Minus x squared into minus 2, that gives me 2x squared, and minus 2x into 2, and so on. Again, in this question also you realize the remainder is 3. Now once the remainder is 3, let's verify the division algorithm. Before the verification, let's quickly identify what is the dividend. Dividend is this entire polynomial, which is a cubic. The quotient is, what is the quotient? Yes, x minus 2, you got it right this time. And the divisor is minus x squared plus x minus 1. This is not difficult terms again, remember. And the remainder is 3. Divisor into quotient plus remainder, is it coming out to be the dividend? Just take a minute, pause for a second and see if it is coming out to be the same. Right? Let's move on. An important example. Find all the zeros of the given polynomial if you know that 2 of its zeros are root 2 and minus 2. Now, what do we do here with this? It's a biquadratic or a quartic polynomial. Remember, we did this in the beginning. It's a degree 4. We already have 2 of its zeros. Let's multiply the 2 zeros. Write the zeros as, that is, these two become factors of the given polynomial. When we multiply, we get, remember it's a minus b, a plus b, so it's going to be a square minus b square. It gets x squared minus 2. That means when 2 zeros are already given, then can we safely multiply them as factors and divide the polynomial? Yes. What shall we get in that case? The polynomial will get equally divided. So we multiply the given polynomial by x squared minus 2, which we've just achieved, and hence when we solve using the same procedure that we've been doing, we get a quotient. Right? Nothing difficult in this. But one thing to remember, if these two, root 2 and minus root 2, are actually zeros, it's going to fully divide the polynomial, that is the remainder will be 0, and that's a check for you. What do we do next? Have we got the other zeros? No. Remember, it's a biquadratic. How many zeros will it have? 4. Remember, 2 we already have, root 2 and minus root 2. The other 2 are going to get through, remember the factor theorem? Yes, it's going to come from the quotient. That is, now we're going to factorize the quotient. So, can you see 2x to the power 4 minus 3x cubed minus 3x squared plus 6x minus 2? What was that? That was the dividend. This is equal to x squared minus 2, that is the divisor, into the quotient. If you keep on comparing, the quotient is 2x squared minus 3x plus 1. Now we need to factorize the quotient because we've already factorized this and we get root 2 and minus root 2. So now by splitting minus 3x, remember the middle term, that is we're going to split the middle term to factorize. We factorize 2x squared minus 3x plus 1 as 2x minus 1 into x minus 1. So it's 0 zeros are given by, how do we get the zeros? Yes, we equate this to 0. We get x equal to 1 by 2 and x equal to 1. Are we getting all the 4 zeros? Yes. 2 we already had, remember? Root 2 and minus root 2. And 2 we just got them, that is 1 by 2 and 1. And therefore, all the zeros, remember? Find all the zeros. 2 we already have, the other 2 we get, and hence all the 4 zeros are root 2 minus root 2, half and 1. Right? This is a pretty important type that encompasses all the division algorithms, all the concepts of factor theorems, in fact some concepts of zeros of a polynomial also all into one. Let us try this together. Obtain all other zeros of the polynomial px equal to 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. God, it's a big polynomial. Are we scared? Not anymore. It says the polynomial is 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5 if two of its zeros are a big root 5 by 3 and minus the square root 5 by 3. Can we use them? Yes. X minus the first 0, x minus the second 0. And we get x minus root 5 by 3, x, remember minus plus root 5 by 3. Right? Now once we solve again, we're going to have a minus b, a plus b, it's going to be x squared minus root 5 by 3 whole square, which is, we are simply going to get x squared minus 5 by 3, and this becomes my divisor. Solution steps. Let us first find the divisor, which is, yes, we found it, x squared minus 5 by 3. Now, we divide the polynomial, which is the polynomial, the given big polynomial, by the divisor and get some quotient. Remember, the remainder will be 0 in this case. That's a check. You know, while solving, if you find that the remainder is not coming out to be 0, check your calculations again. There is no harm in checking them again than to get them wrong. So, note that the remainder will be 0 in this case. Then you factorize to get to the quotient to get the answer, which is x equal to minus 1 and minus 1. Now, which are all the zeros of the polynomial? They are going to be minus 1 and minus 1. Yes, and the other zeros, which was root 5 by 3 and minus root 5 by 3. Remember, you are asked all other zeros, right? So, all other zeros will be minus 1 and minus 1. But once they say find all zeros, remember, it's just a matter of a word in English, but it makes the entire question different. All other zeros, that means just minus 1 and minus 1. But when it says all zeros, it's going to be minus 1, root 5 by 3 and minus root 5 by 3. So we've done division algorithm for polynomials also. Where we did factor theorem, which is revised in a bit. Then we actually divided two big polynomials, wherein we did just one trick and a tip, and then we found different zeros, in fact all the zeros of a given biquadratic polynomial also. What have we learned so far? That was quite interesting. Zeros of a polynomial, when we did zeros of a polynomial, so this is nothing simply but a mind map, a concept map, wherein we are going to map all that we've studied together. That is, zeros of a polynomial, we did the geometrical representation. Remember the graphs that we made? Then, relationship between zeros and coefficients, wherein we did sum and product of zeros, and we formed a polynomial using them. Then, in the division algorithm that we just did, you can see the traces here. Long division and finding all zeros of the given polynomial. Right? Independent practice. Practice the following questions. And I have, that's a bit of technical glitch, let me tell you. No, it's not a glitch. Yes, it's come. Extra questions for polynomials. You've got 7 questions, right? And you can note down the questions, you can solve them, and definitely we're going to discuss all these 7 once we meet in the class. right? To end it now, I would suggest, children, you've got a lot of questions to practice. Just practice as many as you can and you get all the help that you need from us. That was all from my side for this chapter. Meet you in the class. See you next time.